Thanks for watching the 7th edition of AI Weekly Update from Henry AI Labs. This week features a lot of posts about reinforcement learning, like Berkeley's success of controlling a robotic hand on tasks like boating ball rotation, things like the new SPIRAL++ model from DeepMind using reinforcement learning to draw pictures, and Google using reinforcement learning to control quantum computers. Also new datasets like Google's Paraphrase understanding, Facebook's neural code search, and then many other things around the world of the AI sphere. This AI Weekly Update will cover the path's perspective on value learning, a tutorial from the Distill publication, the deep dynamics model for Dexterous manipulation by Berkeley's AI Research Lab, as well as their site page showing you more details about the training and the algorithm itself, Google's using reinforcement learning to control quantum computers, the release of new datasets for paraphrase understanding, multilingual speech recognition system, Facebook's release of new neural code search datasets using Stack Overflow question-answer pairs, the SPIRAL++ model from DeepMind, the release of TensorFlow 2.0, notebook to help you get started with TensorFlow 2.0, and the tighter Keras integration, the extension of the PyTorch transformers from HuggingFace into being able to be used in TensorFlow 2.0, things from NVIDIA like the Jetson Project of the Month for September, the GauGAN used to facilitate artistic applications, using generative adversarial networks to augment datasets for brain disease detection, using conversational AI startups and building platforms to help you build voice-assisted applications, integration of things like the Drive AGX software stack from NVIDIA, and the Skydio 2 drone, and the new capability of being able to detect 10 objects at a time using this Jetson TX2 embedded system, the TensorFlow TensorRT integration, NVIDIA's TensorRT inference speedup with the TensorFlow 2.0 library, the Deep Learning 1990 to 1991 post from Jürgen Schmidhuber, and the LossLandscape shared by Jeremy Howard, and Causal Bayesian networks from DeepMind, and then this week's edition of TheBatch. One of the biggest updates in AI this week is the release of TensorFlow 2.0. TensorFlow 2 has many new features detailed in this video with their Medium post, things like tighter integration with the Keras API, eager execution by default, and emphasis on a Pythonic style. They have a more complete lower-level API now, so you can do things like creating your own optimizer easier than before you could with TensorFlow 1.x. And then they have a standardized save model API for things like deployment on the cloud, web, mobile and embedded systems, things like TensorFlow Lite and TensorFlow.js. Also, interestingly, is the distributed training strategy, distribution strategy API, so that you can do distributed training just with the Keras's model.fit function. Many performance enhancements. They cite TensorFlow 2.0 delivers 3 times faster training performance using mixed precision. And then they have things like a tighter integration with the TensorRT to facilitate inference time on the NVIDIA GPUs. They also have added a TensorFlow datasets library with a standard interface for images, text, and video datasets and more. And they've collaborated with DeepLearning.ai and Udacity to publish many courses and tutorials for using TensorFlow 2.0 linked at the end of the Medium post. Additionally, with the release of TensorFlow 2.0, Francois Cholet, who is a researcher at Google and creator of the Keras API, has published this Google Colab notebook to help you get started with using TensorFlow 2 and Keras. So this notebook has a lot of examples, starting off with TensorFlow things like defining variables and miscellaneous things like this, a linear regression example. Then it gets into Keras, quickly describing how Keras fits on the spectrum of low-level architecture APIs to high-level, and then the low-level to high-level training APIs. Things like the functional API and the difference between how that's more low-level than the sequential model, with the functional API being you kind of do like, you pass in the previous feature map to the next layer more explicitly than the sequential model where you just kind of infer the next layer by just doing like model.add the next layer. And then so the notebook takes you through a lot of different little examples of using the Keras API with the TensorFlow 2.0, and then finally ending with an example of building a variational auto-encoding. Following the release of TensorFlow 2.0, HuggingFace has adapted their transformers library to be used in TensorFlow 2.0 and as well as the Keras API. Also interestingly is they have this sort of switch between TensorFlow and PyTorch that you can do when you're using these transformer models implemented by HuggingFace. So previously you would have to install PyTorch transformers, but now it's just pip install transformers. And this tweet from Thomas Wolfe shows you how they've released 8 architectures in the TensorFlow 2.0 and PyTorch because you can switch back and forth. They have 33 trained models in 102 languages. And then really interestingly is this starter code for getting started with building a BERT model and testing it in Keras, which is new for this HuggingFace libraries to be able to use it in Keras and TensorFlow. Berkeley's AI Research Lab posted a really interesting blog post about the success of model-based reinforcement learning for deep dynamics models for dexterous manipulation. So in this task, there's this 24 degrees of freedom robotic hand that's rotating these boating balls in its palm as sort of a sample task to demonstrate ability of dexterity. So using just 4 hours of real-world data, which is really interesting, one, because 4 hours isn't too long for these model-based systems to learn their dynamics models, and then second, because it's in the real world, which is really interesting, opposed to these agents that learn in simulation. So you can see the overall architecture of their system. They have their data, they learn the dynamics model, which in model-based reinforcement learning is like that transition function P, S prime, and R, the next state reward pair given a current state action input. So they're learning this mapping with the dynamics model, and then they have their policy, the mapping of states to actions, which is the controller that utilizes the dynamics model to control the robotic hand and move the boating balls around. So one of the interesting characteristics of successfully learning the dynamics model with the neural network is that it transfers well, because they have the, shown here, the model reuse, is that when you have this dynamics model, it's really good for transfer learning with the dynamics. And then also interestingly is some successes on simulated tasks as well, particularly the success on the handwriting model, which is really interesting. The corresponding website page of the Planning with Deep Dynamics paper gives you more details about how the experiment is set up if you're interested more in learning exactly how this system of training the boating balls rotating hand is operated, as well as seeing the progression and how it learns across 0 to 0.25 hours and up to the 2 hours where it's learned to juggle the balls. Also interestingly is you can see how long it's taking it to learn these different tasks in the simulated environment, like turning the valve or doing the handwriting task or rotating the cube. So then you can also see more visualizations on the model reuse with the dynamics model, and then more on the handwriting model and simulation. Model-free reinforcement learning techniques learn from experience to estimate the values or the expected returns of intermediate states or intermediate state action pairs. This article from the Distill publication gives you a great visualization, interactive animations on the past perspective on value learning. So the article starts off by showing you how the Monte Carlo, temporal difference, and Q-learning, some of the most important foundational algorithms for model-free reinforcement learning, how they evaluate these intermediate state values based on the return that they received across different trajectories. So you can see when the Monte Carlo algorithm takes this path and receives +2, then takes this path and receives -1, it then will attribute this intermediate state that was experienced in both of the trajectories as a hybrid of the two, which in this case is +1. So the article goes through the different algorithms: Monte Carlo, temporal difference learning, Q-learning, SARSA, expected SARSA, off-policy, double Q-learning. Some of the best characteristics of this article that makes this such a great learning resource is all these interactions that you can use to just visualize the kinds of concepts that are being discussed in the article. And probably the best visualization is at the bottom of the article, where you can test it with an agent and see interactively how these Q functions, which are these state action pairs of moving up, right, down, left, are being updated with respect to the different learning algorithms: Monte Carlo, SARSA, expected SARSA, Q-learning, and then overall you can change whether you want to see the Q functions or if you want to see the value functions of the states. And then you can also mess around with the exploration trade-off with this epsilon greedy policy scale, which is basically whether it takes the action it believes is optimal or whether it behaves randomly. Google's AI blog describes some successes they've had with using reinforcement learning to improve quantum computation and particularly reduce this quantum error gate rate, which I'm not really an expert on quantum computers, but it's still interesting to see the application of these reinforcement learning algorithms for control systems. So they describe in their blog post about how they have this state to action mapping with a policy neural network, and then how they use a neural network to estimate the value functions of states. And it's definitely interesting. You can check out their full paper, Universal Quantum Control Through Deep Reinforcement Learning, where they go more into their system and describe more about quantum computers and miscellaneous domain-specific ideas within this system if you're interested in this. Google's released 2 new datasets, Pause and PauseX, to improve natural language processing models, particularly so that they can identify the paraphrasing pairs and non-paraphrasing pairs, which is best shown in this flights from New York to Florida is still the same as flights to Florida from New York semantically, whereas if you switch it and have flights from Florida to New York, that's different, but this kind of difference would be very difficult for models, even like BERT, to tell the difference between. So this dataset, Pause, Paraphrase adversaries from word scrambling, contains about 108.5 thousand labeled pairs, sourced from this Quora question pairs dataset, which is where you have people asking questions on Quora, like what are natural numbers compared to what is the least natural number, which isn't labeled as a duplicate, but questions such as should I learn Python or Java first, and then if I had to choose between learning Java and Python, what should I choose to learn first, is the same question. And they had this challenge that was released on Kaggle to have you look through it and build models that can detect the similarity of question pairs. So using this data set of the pause and pause X, or probably just the pause X is about multilingual type of thing, so it's probably not useful for the Quora question pairs, or very limited use. But using this, they improved the BERT accuracy from 33.5% to 83.1 on this Quora question pair similarity by fine-tuning the BERT model on this pause X dataset. So the pause X dataset is constructed by taking these sentences and then having the language model scramble the words, and then having a human judgment evaluate if it still has the same meaning or not. Google posted a really interesting description of a multilingual automatic speech recognition system that utilizes attention to build on the model architecture from the previous modifications to the recurrent neural network transducer model. So previously they would have single models in each of the different languages that do acoustic, pronunciation, and language models, all to decode the speech signals into text. But then they started to share the acoustic and pronunciation features, but they'd still be separate models, whereas this attention model is combining the acoustic, pronunciation, and the individual language models all into a single architecture through the use of these attention blocks described here. And then they also describe how there is bias in their training data, and it's skewed based on what they have available for training these systems. But overall, it's definitely really interesting to see the attention model giving these models the ability to have a single model that's doing acoustic, pronunciation, and the language model is all the same architecture compared to having these separate architectures that just interact through these decoding patterns. DeepMind has updated their Spiral paper with the new Spiral++ model. So what this is it uses reinforcement learning for generative modeling of images compared to things like generative adversarial networks, pixel or autoregressive models, or these variational autoencoders that just kind of output the image, compared to having something like this, where you can sort of see how it's like iteratively constructing the images by having the policy map state to actions. And in this case, this state to action mapping is the different like lift, pressure, color, and then like the take it from here to here of the different brush strokes. So Spiral++ is really interesting visualization. I find this to be a little more interesting than the generative adversarial networks, just because of how it's sequentially constructed and you can sort of see it come together. Or, the GANs also have that latent space quality, which is really interesting as well. So overall, a lot of really interesting research in this area of generative modeling of, images, text, speech. So the key differences in Spiral++ compared to Spiral is that they're adding this spectral normalization thing to the discriminator, which is this, basically the Lipschitz constant is like saying it can't grow too fast along any pairs of data points, compared to using this Wasserstein GAN loss in the previous Spiral model. Then things like updating the temporal credit assignment. So the Spiral model previously had a very sparse reward, whereas Spiral++ has more, it's getting rewarded based on how it's improving the discriminator's classification of the how real or fake the drawing is at each time step. Each time step it gets closer to being real, it gets a reward for that, compared to just +1, -1 at the end of the episode. Then we have things like the improving the training of the discriminator by applying these masks so that it has to be, more capable of telling the real semantic differences between images compared to just comparing pixels. And then using population-based training to optimize the parameters of the discriminator, like learning rate, and then this entropy, cost, and the hyperparameters. So it's really interesting. Spiral++, you can see the visualization of drawing out the images to resemble the target images. And then you can see many more examples of their successes with Spiral++ and sort of what these images look like. And then if you're more interested in the real details of the research, I recommend checking out this paper on supervised doodling and painting with improved Spiral. There's been a lot of interesting research data sets coming out with respect to neural code search models. So last week we saw GitHub release this code search net, which is a collection of code pairs where basically they're structured where the doc string is the kind of like description of the code, and then the code in the function or the method described by the docstring is then used as the pair of this data sample. So then, similar to things like GPT-2, where language models are unsupervised multitask learners, we might expect to train language models on these large amounts of code and then expect them to pick up on some of the nuances of the code structure that can then be fine-tuned on things like this dataset released by Facebook, which is a collection of 287 Stack Overflow question and answer pairs from the Stack Exchange data dump, and you would build a model to, to be able to answer questions such as how can I convert a stack trace to a string, and this dataset is done in the Java language, and they also provide more than 24,000 Android repositories, Android written in Java, and to answer these code questions and to solve neural code search, or at least get closer using these different data. NVIDIA's Jetson project of the month for September 2019 is this ShAIdes project of attaching the Jetson Nano to the ShAIdes and then using it to control surroundings in the environment, such as turning on a speaker or turning on or off a light by using gesture recognition with the computer vision in the ShAIdes. So the project is described very well in the GitHub repository. You can see it. The Jetson is attached to the ShAIdes, and then it has these two computer vision models, one to detect the object that you're making the gesture at, and then the other to detect the gesture, and then use it to control some of the interfaces in the environment. So it's a really interesting GitHub repository. Nick has really described exactly how he built it, which is really great. He describes how he's got 13.7 thousand images in the object detection model, and then the 19.5 thousand the images. So he's got these two separate convolutional neural networks, one to detect the objects like the lamp or the speakers, and then another to detect the gestures like the wave, or I'm not sure if there's another gesture. And then also is a really great description of how you can train this on AWS with the NVIDIA Tesla M60 GPUs if you haven't done this before. Things like how he collected his data, how he has this heuristic to speed up the inference, so he can get the images and classify them at a rate of 5 frames per second, which isn't quite fast enough. And then he also wants to have some kind of catch mechanism in case there's noisy predictions, which is described here. So overall, it's really interesting, a cool project, seeing the Jetson in use, able to run these two convolutional networks on such a small device. Really cool. From NVIDIA's AI podcast is an interview with Collie Wirtz, who is an artist who makes these kinds of sci-fi renderings and designing of these ships. And in this podcast, he describes how the GauGAN model from NVIDIA has helped him to accelerate how quickly he can make these kinds of renderings by automatically generating these backgrounds. So you can play around with the GauGAN model by searching NVIDIA GauGAN, and then you'll be taken to this kind of interface where you can test things like drawing flowers on the surface, and then you can render them into different styles. You have all sorts of different images that you can use to base the rendering off of, and you can upload your own segmentation mask if you already have one and don't want to draw it in this kind of interface. NVIDIA posted a spotlight of the Skydio 2 drone, which is a member of their Inception startup incubator program, and they use the NVIDIA Jetson TX2 combined with 6 4K cameras to have this drone that's capable of tracking up to 10 objects at a time, many other things like capable of flying up to 23 minutes at a time, and they have this video where you can see miscellaneous capabilities of the Skydio 2 drone and the computer vision systems that are enabled by the NVIDIA Jetson TX2 module with the 256 GPU cores capable of 1.3 trillion operations a second to process all that data from the 6 4K cameras. NVIDIA also posted about TensorFlow 2.0 with respect to a tighter integration with their TensorRT inference acceleration optimizer. So the TensorRT, when combined with TensorFlow 2.0, particularly in this article, they cite a 7 times speed up on inference, meaning how fast you make predictions. And then it seems like they also are specifically citing the ResNet 50 and BERT-based applications with respect to this 7 times speed up figure. And then the article continues to talk about other things of the TensorFlow 2.0 announcement update that we covered previously, things like the tighter integration of Keras, and then this distributed strategy API that makes it easier to train your models with multiple GPUs. Neurala details an interesting testimony about how a tighter integration between the hardware-software stack of NVIDIA's GPUs using the NGC containers and the TensorRT inference framework has achieved these kinds of speedups in their performance for computer vision models. They see a 4 times speedup in training and about a 7 times speedup in inference by using these NGC containers and having this tighter hardware-software integration. NVIDIA's blog post also covers Clinc, a conversational AI voice platform which is gaining a lot of traction, raising $52 million in a Series B round. And overall, the article describes some of the customers that they have, some of the applications like use in the car, overall being a platform that enables the customers to build voice applications like in-car voice features, fast food restaurant order services, or personal banking assistance by building it on top of their conversational AI platform. NVIDIA also posted an article about using GANs to augment datasets for brain disease detection. So in this article, it describes that using the traditional dataset with about 1,000 brain MRI scans results in a model with around 90% accuracy. But using this PD-GAN model described in the article, the model is able to achieve 96.5% accuracy and then 98% on the certain targeted kind of scan. So it's interesting, this idea of using generative adversarial networks to augment data sets. You take the current data set and then you infer future data points, or like data points that could exist given this data set, and then use this to train the models. It's definitely interesting to see the accuracy performance report in this article. I've seen some papers that do a similar thing. There's a study on using the DC-GAN model to augment these liver lesion images that results in positive performance boost as well. Although I think that the research on using GAN-generated data to augment these data sets is still unclear. It hasn't really worked on ImageNet yet. Probably most successful is a paper called Vector Quantized Variational Autoencoder 2, which isn't quite a GAN model, but is using a similar approach of using a generative model to augment these data sets and give you more data to train on. And I think this is the closest performing model for the ImageNet task of augmenting datasets in this way. NVIDIA details some components of the NVIDIA Drive AGX platform using the TensorRT inference and the Xavier chip in order to enable self-driving cars at level 2+ and level 4 and 5. So they discussed in this article about the CUDA library that's used to run the parallel programming at the lowest level of the stack on the GPUs, and then how they have this NVIDIA Drive AGX, TensorRT to speed up the inference, and how these components work together in order to enable the self-driving car compute requirements. Another really interesting update to AI this week was the inaugural tweet of Jürgen Schmidhuber of Deep Learning, Our Miraculous Year 1990 to 1991. In this article, it presents a lot of interesting ideas in deep learning that are still used. Things like adversarial learning, like generative adversarial networks, a very similar idea. Things like AutoML and the invention of the LSTM networks, all these kinds of things that were kind of invented in this time span. And it's really interesting to hear about sort of the history of deep learning in this way and some of the early ideas and how they developed over time. So it's really interesting to read, definitely interesting perspective into all these ideas. Definitely interesting, the idea of model distillation as early as 1991. Wasn't something that I personally knew before reading this article, and a lot of many other interesting things are described in this article. DeepMind posted an article about causal Bayesian networks, a technique to enable more fairness in machine learning and interpretability with respect to decisions made, and explain the ideas of a bunch of interacting variables and the differences between direct pathways, such as in this diagram the impact of gender on admission rate, and then indirect pathways such as gender that impacts departments, that this indirect relationship on the admissions rate. So this blog post shows things like unfair pathways, and then how unfair pathways can then be rendered through indirect pathways, and discusses how overall these kinds of techniques of causal Bayesian networks can be used to change certain variables and see how it impacts the final decision, like changing a candidate for admission from female to male, and how that would change the output decision in the counterfactual world. Toyota Research released a really interesting video about teaching robots in the home to perform tasks, and doing this in a way that you only need to demonstrate how to perform the task one time in a virtual reality simulation, and then the robots are able to use imitation learning to learn how to perform these tasks. So it's really interesting, these applications of robotics for things like taking care of people and helping with miscellaneous tasks, and a really interesting video showing you how this transfers from simulation in the virtual reality environment, where you show the robot how to do the task, into the real. Another interesting update to AI is this LossLandscape.com, where they are artistically rendering these lost landscapes using low-dimensional projections of the optimizers update space, and creating these kinds of valleys to describe the morphology of how the sort of visualize the local optima and this the gradient descent steps are taking in this sort of way. So I'm not really sure how to interpret these kinds of lost landscapes yet, but if you have a better idea or you're interested in this, please leave feedback in the comments. This edition of TheBatch begins with a note from Andrew Ang relating this book, No Silver Bullet, Essence and Accents of Software Engineering, with new frameworks in machine learning and deep learning like TensorFlow 2.0, and how ideas of reducing the complexity of programming languages is hard, and the overall idea of how reducing the complexity always evolves over time as the problems that we're trying to solve become more and more complicated. The batch describes a leaked research paper from Google claiming quantum supremacy. In this case, they are able to solve this problem, which is supposed to take 10,000 years with conventional computers, but this quantum computer is able to do it in 3 minutes and 20 seconds. So in the world of AI, if these kinds of quantum computers are successful, it would dramatically speed up the computation and totally change the field altogether. It's an interesting kind of idea. It's not something I'm too knowledgeable about, but quantum computers definitely seem like a very interesting emerging. The batch goes on to present anonymous faces with this deep privacy technology, which is a technique to anonymize the identity of facial images and then still have them be useful in applications that rely on facial recognition, basically still being able to use this data to train these deep learning models without having the identity of the people in the data sets. So it's an interesting architecture. They describe how this novel technique, deep privacy, compared to a previous dual-shot face detector, has a higher accuracy when trained with this data. Overall, it's an interesting idea. The batch concludes saying that they're skeptical on the success of this, but they think that this is a interesting step forward. Following this is nothing but neural net. This is a technique that where a basketball coach, say, draws up a play, the AI will simulate how the defense is likely to react to this kind of play. Definitely a really interesting, cool application. And then, so the batch concludes with this idea of maybe having like an AlphaGo like breakthrough in this kind of thing, where this kind of AI can design plays that humans don't envision and develop new kinds of strategies in sports. Then following this is a bill being developed from Amazon to address how facial recognition technology will be used. The batch cites that they have this facial recognition service, Recognition, and how different concerns around the use of facial technology, face recognition, things like being banned in certain cities like San Francisco and Oakland and Somerville, and overall an interesting discussion and interesting law being developed. Following this is a discussion of Salesforce's control model, which is a way of controlling the GPT-2. So if you've played around with talktotransformer.com, a lot of the times you get sort of a random output text generated, so you might repeatedly click generate another until you get some kind of thing that you like. But the control model from Salesforce allows you to embed and sort of condition the language model, such as BERT or GPT-2, in order to get a sequence that is more aligned with your interests, like whether you want a review starting with the knife or you want like a horror novel or something. So it's definitely an interesting technology control, giving you more control over these language models and reducing the variance in the output of these language models. Concluding the batch is a model developed by seismologists to predict earthquake patterns. Interesting application of using deep learning to predict these and model these acoustic signals. Thanks for watching the 7th edition of AI Weekly Update. Please subscribe to Henry AI Labs for more deep learning and AI videos, and please leave any feedback you have on the video in the comment section below. Thanks for watching.